Hello, my name is Xinrui Chen and my net ID is XC856. This is question 1 for homework 10. The question is that from the lecture notes, page 1 to 50, collect the definitions and simple properties of the example of the stochastic processes. The first one is Poisson process. The Poisson process is defined by the following properties. Here, there's 3 properties, and we have the first order probability masses, which is equals to this equation, and the mean value should be lambda t, and autocorrelation should be equal to lambda squared times t1 t2 plus lambda times the minimum value of t1 and t2. The auto covariance should be equals to this one, and the mean of the Poisson process is lambda t, which is a linear function of t. It matches our common sense, which is that the longer time we wait for, the expected number of the buses is larger. And the autocorrelation function contains a term, this one, which comes from the property of independent increments. The second question is the Poisson increments. The Poisson increments process is defined as this equation where xt is a Poisson process. The first order probability masses is this one. The mean value should be lambda. The autocorrelation should be this function, and the autocovariance should be equals to this one. And some discussions for this Poisson increment process is prepare us to define the Poisson impulse process. It is interesting to see that in the expression of autocorrelation, this one, this one is a triangle with area lambda, which is independent of epsilon. When epsilon goes to 0, the triangle becomes an impulse with area lambda. The third one is the Poisson impulses. It is defined as this equation where xt is Poisson process. The Poisson impulse do not have a probability masses, and the mean should be lambda. The autocorrelation should be this equation. The autocovariance should be here. The process zt minus lambda has zero mean and correlation of this one. That is, zt minus lambda should be a white noise. We define it as the output of a linear time invariant system with impulse response ht and input as an Poisson impulse process. For question 4, should be semi-random telegraph signal. It is defined based on the Poisson point. The Poisson point again. Poisson. The number. Sorry. The first order probability masses should be this one, and the mean should be this one, and for the autocorrelation it should be equals to this, and the autocovariance should be equals to this one. And some discussions from for the semi-random telegraph signal is that the probability of xt equals to 1 is not 1/2, because we start with 1. It should be a little higher than 1/2, and it will go to 1/2 when t goes to infinity. The mean goes to 0 when t goes to infinity. The autocorrelation goes to 0 when t1 minus t2 goes to infinity, and which matches the common sense when t1 and t2 far away. xt1 and xt2 are less correlated. Question 5 is about a random telegraph signal. The definition is here. The first order probability masses should be 1/2. The mean value should be 0. The autocorrelation should be this one. The autocovariance should be this one. We have done that the probability of yt equals to 1 equals to the probability of yt equals to -1, which equals to 1/2, and the expected value of yt should be a constant, so that yt may be strict sense stationary. Question 6 is a random walk. comes from a tossing of a fair coin infinite times. And K is a number of heads in n tosses, and we will have this. The first order probability masses is this equation, and the mean value should be 0. The autocorrelation should be equals to the minimum value of n and m times s squared, and autocovariance should also equals to this equation. Some discussions is that from the probability masses, we get that when n goes infinity, we will have Gaussian density. The autocorrelation function contains a term of this one, which comes from the property of independent increments. Question 7 is Wiener process. The first order density function should be this one. The mean value is 0. Autocorrelation is this one. As well as autocovariance is also this one. There are some properties of the Wiener process, which is that W0 equals to 0, WPL. W has independent increments. W has a Gaussian increments, and it should have continuous paths. There are lots of good properties of this linear process.